Well, as always, I'm going to draw this a little more simply. Here's my lawnmower, the weight, the normal force, and the push force comes in like this. But that's not how I like to draw my forces. I like to draw them coming from the object, not going into it. So I'm going to draw it like this, and it has a value of 20 newtons. I'm going to break that into a parallel component and a perpendicular one. And I'm going to remember that this angle here is 60 degrees. Well, I know that this is my equation for work, and delta x I know is this 150 meters. Now, I just need to know F parallel. Well, looking at this right triangle here, I can see F parallels the adjacent side. And carrying out the math, I find F parallels 10 newtons. Multiplying this by 150 meters, I get total work of 1,500 joules. If you got this, very good. Let's go back to our man moving water along the dike to see exactly what was going on. So in this case, the man was lifting upwards with some force, but the direction of motion was this way. Actually, let me just extend this arrow so that we can see this is a right angle. When our vectors are perpendicular in this way, well, no component of force will ever be parallel to delta x. In fact, whenever the force is perpendicular to the displacement, or the delta x, no work is done. One thing we haven't thought about is what happens when the force is in the opposite direction of the displacement.